students, welcome to my class. Today we are going to study salts. We will know all the details about salts, its properties, how it can be prepared, properties as in physical and chemical properties, types of salts, of course it is there, and I will be discussing the questions, also the types of questions that you can get. So children, I believe you all have watched the video on acid and the other one on bases, and this one is on salt, which comprises one chapter altogether. So children, please like, share and subscribe my channel, and let's begin. So to repeat myself, that I will be sticking to the syllabus and do all the parts of the chapter, and you are actually expected to watch the video. Of course, it's going to help you read the chapter and do the 10 years question paper, and if there is any doubt, please put it in the comment section. I'm going to clear them all. Very soon I will be putting up a video on how to read the question paper and prepare you how to face the exam, and after that I will be discussing the 10 years question paper and revise a little with you all. So for now, salts, and the topics that we are going to discuss today are types of salts, preparations, physical properties, chemical properties. Okay, this is the content. So let's begin. Okay, so first let's know what are salts. Salt is a compound which is formed by the partial or total replacement of the ionizable hydrogen atom of an acid by a metallic ion or an ammonium ion. So basically, when you have, if you have gone through the video of bases and acids in the definition itself with example also, I've told you there how a salt is prepared only when the acid and base react with water. The product is salt and water only, and the composition of a base and an acid. So here the basic concept is that a compound which is formed by the partial or total replacement of this partial and total we are going to do a little more in the further slides, of the ionizable hydrogen atom of an acid by the metallic ion or the ammonium ion. So this is the partial replacement. You have done this when you were studying the laboratory preparation of nitric acid. See, sodium nitrate, even HCl. Sodium nitrate in this case with conc H2SO4 at a temperature less than 200 degree, where the hydrogen is partially replaced, you get sodium bisulfate. But for the complete, at a temperature greater than 200, you are getting sodium sulfate, where you don't have hydrogen. This is the difference between partial and complete. Ionic definition, of course you know that it's an ionic compound which dissociates in water to yield a positive ion other than hydrogen ion and a negative ion other than hydroxyl ion, because the hydrogen of the acid and OH of the base is already giving you water. That's what is a definition. So you are not getting H plus positive or OH minus, and it's an ionic compound like sodium chloride Na plus and Cl minus. Okay, so we can take one more example of neutralization, where an acid and a base reacts, NaOH and HCl, giving you NaCl and water only. I guess I was very clear in my video previous one about only. So coming to the classification of salts now, there are actually 6 types: normal salts, acid salts, basic salts, mixed salts, double salts and complex salts, which we will do one by one. according to your syllabus, you can check what is not there in your portion. You can miss that part, but I basically make up the video so that your bases are clear. All the little bits or all the little knowledge that you should have at this level of 9 and 10 about salts I have given you. Maybe all that little bit will not be there in your portion, so let's not think about all that we only stick to the examination point of view, and we are having partial knowledge. So coming back to the normal salts, the first one, normal salt, it's nothing but the salt which is formed by the complete replacement of the ionizable hydrogen atom of an acid by the metallic or the ammonium ion, which we discussed just now in the previous slide. For example, when HCl and NaOH reacts, CH plus and OH gives you water and NaCl. Here also, with an acid and a base neutralization reaction, complete replacement of the hydrogen from the acid and the OH or from the base is giving you water, and the rest combines to give you a normal salt. They have an all the normal salts, this do not have any ionizable hydrogen atom, because all that is there because of the complete replacement and it becomes water. Let's go to the next slide, where we have acid salt. The name itself suggests that these are formed by the partial replacement of the ionizable hydrogen atom of the polybasic acid. It can be monobasic. It cannot be monobasic because there is only one hydrogen. It can be dibasic acid, where at least one hydrogen remains in the molecule of the salt that we did just now, sodium bisulfate. We had done it just now. The other examples are sodium bisulfite, sodium biphosphate, and so on. These are usually formed when the amount of base taken is insufficient for the complete neutralization of an acid. So acid and base neutralize each other when the hydrogen ion of acid and the OH ion of the base combines together to give you water. But if there is less amount of bases present, it is not enough, not sufficient to completely neutralize the effect of acid. It gives you a acid salt where an ionizable hydrogen is still there in the molecule. So the acid salts ionize in water solution to give hydronium ion, and therefore they show all the properties of an acid. The next type, we come to the basic salt. The name here suggests again the basic salts are formed by the partial replacement of the hydroxyl group. Now we are coming to the base. So hydroxyl group of a di or a triacidic base, because monoacidic base will have only one hydroxyl. So partial question doesn't arise. So a basic lead chloride, a basic magnesium chloride, a basic copper chloride, where you have OH in the molecule of the salt, which is due to the partial replacement of the hydroxyl of the base. So PbOH whole 2 with HCl will give you a basic lead chloride with water, and these contain a metallic cation, a hydroxyl ion, and the anion of an acid, of course, because it is a salt form. So the ionic nature will be there with a cation and an anion. To the next one, a double salt. A double salt, asterisk marks are there because in some book they say it is not there in the syllabus, but yes, you should know, because these compounds are all there in your syllabus, so you should know about them. So a double salt, these are formed by the union of two simple salts that dissolve in water and crystalline. So potash alum, Mohs salt, dolomite, these are combination of two simple salts together. Mixed salts are those salts which contain more than one basic or one acid radical, like sodium potassium carbonate. See, sodium potassium, two cations and a carbonate, or bleaching powder, calcium oxychloride. Complex salts are those which on dissociation gives one simple ion and one complex ion. Like you can talk about silver argentocyanide, which we were doing when we were doing electrolysis, and one of the application was silver coating, and the electrolyte used was sodium argentocyanide or potassium argentocyanide with a simple ion, sodium ion, and a complex ion, argentocyanide. Okay. So others are silver aminochloride and tetrachloride sulfate. Tetrachloride sulfate, we did it where? In the analytical chemistry. Potassium mercuric iodide, sodium zincate, these are all there in your chapters somewhere or the other, so you should know how to classify them. Up to this, if you have to talk about the types of questions, of course there can be first question, define a salt. Don't forget to give one example. What are the types of salts, or all kinds of salts that it can be classified into. Definition of a normal salt, examples. Definition of an acid salt, example. Definition of a basic salt with example. These examples I believe you should not leave, even if you are skipping the definition. Okay, so next we now come to the preparation of salts, which in a way we have already done if we are talking about study of the compounds, or if you are talking about the practical chemistry, or any of the chemical behavior. We always see the method of preparation, or the equations which we are going to do here are already known. So first one, it is direct combination, where elements combine, that is sodium and chlorine will give you sodium chloride, iron and chlorine will give you ferric chloride. If we come to simple displacement, a metal into an acid will give you salt and hydrogen. So these are the examples. See, this is ferric chloride and this is ferrous chloride. So I guess one question you are going to get from here, either they will directly give you to complete this equation iron plus chlorine, where children make a mistake giving it to ferrous chloride, children remember, or they ask you to give you one equation to prepare ferrous chloride or ferric chloride, or they can give a conversion, but they normally don't miss it out. Now decomposition. Now decomposition of a salt, a carbonate salt, a sulfide salt, or a sulfide salt, or a bicarbonate salt, and with an acid, which we know with a carbonate or a bicarbonate gives you salt, water and carbon dioxide. With a sulfite, it gives you salt, water and sulfur dioxide. With a sulfide, it will give you a salt and H2S gas, which we have done it so many times when we were doing HCl chapter, when we were doing sulfuric acid chapter, when we were doing the practical chemistry as well. So it's a repetition, and the examples are also known to you. So I guess if you go through, these are the simple ones, okay, which you have already done in the chapter of HCl, nitric acid and sulfuric acid in the study of compounds. So not new, but yes, preparation, you will at least get a 2 marks question from here, I guess so. Next, neutralization. This is very important here, which is very common topic which you had been doing in standard 7. You did it in 8, you did it in 9, you've done it this year also. But this word titration is something which you should know, that a neutralization reaction normally takes place with the help of titration, where the acid reacts with the sodium hydroxide or ammonium hydroxide to give you a salt and water. Okay, the neutralization of acid with an insoluble base like metallic oxide, lead oxide, copper hydroxide, which we had discussed in the previous video, giving you again salt and water. Yes, insoluble bases in water, we did it if you remember. And then the action of the alkalis on certain metals aluminium and zinc, aluminium oxide, zinc oxide, lead and zinc. We have done it in the analytical chemistry and also discussed about it when we were talking about amphoteric metal, amphoteric oxides and amphoteric hydroxides. So these amphoteric metals or their oxides and hydroxides with bases will give you salt and hydrogen or salt and water. Please try to guess what type of salt they are. We have done it just now in the previous slide. So I guess this will help you to remember. And you should also be able to reason it out why they are of that kind of salt. Okay. Soluble salts are prepared in solution only. So the soluble salts are obtained by the evaporation crystallization method. If you remember last year's separation chapter. Some soluble salts like zincate and aluminate are found in solution. So they cannot be obtained as pure form in the form of crystallization. But basically soluble salts can be prepared by crystallization method. This we have done it earlier. Okay, so now preparation of insoluble salts. Now salts can be soluble and salts can be insoluble also. For a soluble salts, we saw the method of preparation just now. About all that we had discussed earlier also. But there are certain salts insoluble which can be prepared also. First one, the direct combination or the synthesis like sulfide, lead sulfide, iron sulfide, they are insoluble. Generally leaving the sodium, potassium, ammonium, rest of the sulfides are insoluble. And sulfides and carbonates are also insoluble. So you can also do it by combination reaction. This is synthesis, this is combination where sulfur dioxide, calcium oxide gives you calcium sulfide, carbon dioxide, calcium oxide gives you calcium carbonate. There are certain which we get from double decomposition. Also, if we talk about acid with reaction with acid, all the chloride salts with a sulfate, barium chloride. This is the salt which identifies the presence of sulfate in a salt. So barium chloride with sulfuric acid will give you barium sulfate, which is insoluble and it is formed as white precipitate. So does silver nitrate. Silver nitrate and HCl will give you, because silver nitrate is the reagent which we take help of when we identify chloride, and it will give you the white precipitate of silver chloride because silver chloride is insoluble. So does lead carbonate, barium sulfate, copper sulfide and so on. The equation somewhere or the other you have done, but you have to remember, because the question will be put you in the form such that they can extract from you whether the child knows that it is a soluble salt or an insoluble salt, whether the child knows the technique, the child knows the difference between the types of salts that are soluble and the technique to find out which is a soluble salt and insoluble salt. The next, we can also find out an insoluble salt can also be obtained from another insoluble salt by double decomposition. So if one salt is insoluble, then that has to be converted into a soluble one, which further reaction will give you another insoluble salt. So it's basically one insoluble salt to be obtained from another insoluble salt. For example, insoluble lead sulfate, it has to be prepared from insoluble lead carbonate or lead oxide, both are insoluble. So metallic oxide like lead oxide, insoluble. All carbonates I said are insoluble, so lead carbonate is also insoluble. And you have to find out lead sulfate, all the sulfates are also insoluble. So this has to be converted to one nitrate, all nitrates are soluble. So in that case, to convert it into one nitrate, you have to react it with nitric acid, so that metallic oxide with nitric acid will give you metal nitrate and water. So this lead nitrate is now to be reacted with sulfuric acid, so you get a lead sulfate, which is again a white precipitate. If it was a carbonate, react it with nitric acid to give you lead carbonate, because any metallic carbonate with acid will give you salt, water and carbon dioxide. We need the salt, lead nitrate. This to that, if you add sulfuric acid, you get the white precipitate of lead sulfate and sodium nitrate. So this is very important. This particular part is very important, and I'm sure you're going to get one question from here because it is up to that level. Okay, so the next, you can even prepare silver chloride and barium sulfate, which we discussed just now, that silver nitrate reagent is used to identify any chloride and barium chloride is used to identify any sulfate. So definitely you are getting the insoluble salt of silver chloride and barium sulfate, and both are white precipitate. About this we have already done in the practical chemistry. Silver nitrate in the HCl chapter, barium chloride in the sulfuric acid chapter, sorry. So it is a repetition. I am sure those who are preparing very well must understand this. Coming to the properties of salts. So the general properties are, the salts are electrovalent compound, yes, ionic compounds. So definitely they will conduct electricity in their molten state as well as in the aqueous state due to their dissociation into ions, as it is an ionic compound. The non-volatile solids that form crystals. Most of the salts are soluble, and the degree of solubility in water varies with temperature. So this variation of solubility of salts with change in temperature, we have done it last year. Let me do it once again. If you increase the temperature, the solubility increases or decreases, depends upon the salt. So if we take the example of calcium sulfate, it will increase very little and then decrease. Potassium sulfate will have a little increase with increase in temperature. Sodium chloride normally don't have any change. If we talk about potassium chloride, its solubility is much more at 0 degree and will increase a little. Whereas potassium nitrate will increase abruptly with the temperature, and potassium sulfate also will increase a little. So these are some of the salts which solubility, I guess last year you had to learn it by hearted because it was one of the important part to be asked in the question paper. So you have done it also, it's a repetition. Coming to the next, how do you know it's a soluble salt or an insoluble salt? If the amount dissolved in 100 liter at a particular temperature is up to 1 gram, it is soluble, but if it is less than 0.1 gram, it is taken to be insoluble. Now just now I was talking to you all about the solubility of salt, very very important, and the types of question also I will discuss. Actually all salts of sodium, potassium and ammonium are water soluble, be it a chloride, a sulfate, a sulfite, a carbonate, whatsoever. Any salt of sodium, potassium and ammonium are water soluble. All the nitrates and all the nitrites are soluble. There is no exception. All the chlorides, bromides and iodides, that means I am talking about the halides, they are all water soluble except these here: silver chloride, mercury chloride, lead chloride. Exception, these three. But lead chloride, PbCl2, it is soluble in hot water, but it is insoluble in cold water. The moment you heat the test tube, you see you don't find any precipitate. When you allow it to cool in the test tube stand, you will see white precipitate. So PbCl2, please remember, it is generally asked. Exceptions, it is generally asked. All the sulfates are soluble, leaving calcium sulfate, lead sulfate and barium sulfate. Please remember. All the carbonates, sulfides, sulfite and phosphates, they are insoluble. But as I said, any salt of sodium, potassium and ammonium will be soluble. So this is the exception. Now what kind of question is asked from here? Name a chloride salt which is water soluble. You can give anything leaving these three. Name a chloride salt which is insoluble. Name a nitrate which is insoluble. Your answer will be all nitrates are water soluble. Name a carbonate which is soluble. Anything, sodium, potassium, ammonium. Rest of the carbonates are insoluble. So this table, this particular table, if you are remembering the naming questions, I guess at least 5 questions from here, which is definitely there in the question paper. They twist, but they ask. All metallic oxides and hydroxides are insoluble except, as I said, sodium, potassium and ammonium. Calcium hydroxide is slightly soluble, so that's a little exception, otherwise you know it. We come to all metal oxides and hydroxide insoluble except this, as I said, but bisulfates are sparingly soluble, like sodium bicarbonate and potassium bicarbonate are sparingly soluble. The next topic with us will be hydrolysis of water. This is also a repetition. I know we did it last year, but to repeat it once again. The phenomenon due to which the salt formed by a weak acid and a strong base, or a strong base acid and a weak base, react with water to form an acidic or an alkaline solution. So if it is a weak acid and a strong base, the solution will be alkaline. If it is a weak base and strong acid, the solution will be acidic. So the salt formed by strong bases like sodium hydroxide and potassium hydroxide, and weak acids like carbonic acid or acetic acid, the hydrolysis of water will give you pH value more than 7. That means alkaline, because these are strong bases. So examples are given here. The next example I will see, where the salts with strong acid and weak bases with water will give you acidic solution. The examples are ferric chloride, copper sulfate, because chloride, HCl, strong. Ferrous hydroxide, weak base, so strong acid and weak base. So this you should remember, children. Salts derived from strong acid and strong bases are neutral to the water, because these are examples of complete dissociation, NaCl, sodium sulfate and so on. Some salts are formed from weak bases like ammonium hydroxide, and weak acid like acetic acid. So they may be acidic, alkaline or neutral depending upon the dissociation or the undissociated molecules. How much it gets dissociated, the solution will be accordingly. This is little different from the other two concepts we did it just now. So basically hydrolysis is a strong base and a weak acid in water will give you a basic solution. A strong acid and a weak base in water will give you a acidic solution. A strong base and a strong acid together will give you a neutral solution. It only goes a little different for the ammonium salts. Next slide. There are some salts containing water of crystallization, and you know what the water of crystallization is. If a salt solution is made and the solution is saturated, heated, supersaturated and then cooled using seeding and all that, you get crystals, the salts in the crystalline form. They will have some spaces for water molecules, so these are known as water of crystallization. So there are some of the common names, the chemical name and formula from where at least 2 questions please expect in the question paper, be it washing soda, Epsom salt, potash alum, global salt, blue vitriol, plaster of Paris, white vitriol, gypsum, green vitriol. It is not there now, but it's there in your text. You should know all the common names, their chemical names and their formulas. I guess question from here for sure. So this table is very important. Do not leave it. Next slide. If we come to the preparation which I was discussing with you just now, and we get to know about how water vapor is tested. So we all know the blue copper chloride turns pink with water, and there are some salts which do not have water of crystallization. They are common salt, nitre, common salt, nitre, sugar, potassium permanganate, ammonium chloride. So on heating, sodium chloride decrepitates. This we have done when we were doing practical chemistry. So decrepitation or crackling sound is given by sodium chloride. Remember the names of the salts with water of crystallization, and these are the salts without water of crystallization. This is also asked. Basically, a child should know the names of the salts without and with water of crystallization. Certain important properties. Efflorescence, very interesting, and for sure you are getting a 3 to 5 mark question from here. Efflorescent, it is a property of some salts to lose wholly or a part of water of crystallization when that salt is exposed to dry air, open to the atmosphere, is kept, and it loses the water of crystallization and it becomes powdery. The crystalline nature changes into powdery nature. These are efflorescent substances. They lose their water of crystallization, thus the crystalline shape is lost. Examples are washing soda, Glauber's salt, Epsom salt. Remember the definition, remember the example names, remember the formula of the examples. Okay. So more the temperature, more will be the efflorescence. The next topic, hygroscopy. There are some salts which will absorb water vapor from the moisture, and without dissolving in it, they will lose their crystalline nature. The salt will absorb moisture, but it will not change into liquid. They are known as hygroscopic. They will absorb the moisture from the atmosphere. And the examples are Kong sulfuric acid, phosphorus pentoxide, quicklime, silica gel. Remember the names and the formula. The next topic, deliquescent. Certain water-soluble substances, when exposed to the atmosphere, will absorb the moisture from the atmosphere, just like the hygroscopic, but will ultimately dissolve in the absorbed water and form a saturated solution. That means the liquid part will be formed, which is known as deliquescent, and the examples are caustic soda, caustic potash, formula is important, magnesium chloride, zinc chloride, calcium chloride, ferric chloride, zinc nitrate, copper nitrate. So first the oxides names are given, the chlorides names are given, the nitrates names are given. Please learn them. The deliquescence occurs when the water vapor pressure of the salt is much lower compared to the atmospheric vapor pressure. So efflorescence substances will lose the water, where the hygroscopic and deliquescent will gain the weight from the atmosphere. But the table salt, this is a little exception, you can say, and an important question which is generally asked. The table salt turns moist and ultimately forms a solution, but sodium chloride is not deliquescent. When we say table salt, common salt, we know it is sodium chloride, but sodium chloride is not deliquescent. We studied just now. It is, but when you keep it open, it will turn into liquid. The reason behind is that it contains magnesium chloride and calcium chloride, which are highly deliquescent in nature. So they will absorb the moisture, and therefore sodium chloride being soluble will definitely dissolve in it. So this is one important point you should all know, where pure sodium chloride is produced as a it can be filtered and then taken out, but yes, table salt, if we say, it's a general idea. You take salt in a plate and keep it open on the table. After maybe a few hours, 7 to 8 hours, you come back and check, it becomes little moist. More in the rainy season you can see. It's just because of that magnesium chloride and calcium chloride. Next comes drying or dehydrating agent. The drying or desiccating agents are certain substances which remove moisture from any substances. They are almost hygroscopic substances, okay, like Kong sulfuric acid, phosphorus pentoxide, silica gel. But when we say dehydrating, these are substances that remove water molecules even from compounds. That is, Kong sulfuric acid can do it. I can show you with example. that drying agent, they remove moisture from other substances. Dehydrating chemically remove. So the physical change, drying of course, a chemical change, dehydrating because from the compound it is being removed, and the examples are written here. So I think this is all that is there in your syllabus. Children, please go through the chapter, watch my video. I have covered every single part of the chapter, including the definition, the types, the examples, the explanation, the properties, the preparation, the differences, and I am sure you are not going to get any difficulty in the chapter. There are a little bit of laboratory preparation also, but the method of preparation is included in the preparation part, so you will not have difficulty. I'm sure children, you are liking my way of teaching you in the YouTube. Please like, share and subscribe my channel, and put your doubts in the comment section. Okay children, take care. Bye.